At 3:14 a.m., the frog looks completely dead. Its eyes are cloudy. Its legs are hard. Ice crystals press against its skin. By sunrise, it wakes up and hops away. That sounds fake. It is real, and it is only the first impossible animal tonight. We are not counting biggest animals. We are not counting cutest animals. We are counting biology that feels like broken physics. Some animals freeze, regenerate, aim, mimic, or outfly mountains. One even seems to escape aging itself. But which ability sounds most impossible and still happens naturally? Start with the frog that turns winter into pause mode. The wood frog survives freezing by changing its body chemistry. Most people think ice always kills cells. The truth is stranger. Too much ice inside cells is deadly, so the frog moves water away from sensitive places. Its liver floods the body with glucose. That sugar acts like emergency antifreeze. Blood flow stops. Breathing stops. The heart can stop too. Up to 65% of its body can freeze. That is not movie magic. That is recorded biology. Researchers found frogs reviving after nights buried in leaf ice. Its organs do not love freezing. They endure it carefully. Ice forms mostly outside cells, not deep inside them. That small difference changes everything. Winter becomes a storage state. Spring becomes a restart. And if that feels impossible, the next hunter bends optics. An archer fish sees a bug above water. Then it spits a bullet from below. The bug drops. Lunch solved. That shot looks simple. It is not. Light bends at the water surface, so the bug is not where it seems. Most people miss that distortion completely. The fish corrects for it instantly. That means angle matters. Distance matters. Surface ripples matter too. Yet the fish still hits. Some shots can knock prey from around 2 meters. For a small fish, that is serious range. It also changes the water jet mid-flight. The stream starts narrow, then it bunches into a stronger impact pulse. Scientists filmed that change with high-speed cameras, so it is not random spraying. It is shaped fluid engineering from a fish brain. Young archer fish get better with practice. That part matters. Instinct starts the skill. Learning sharpens it. And another animal upgrades perception itself. The mantis shrimp does not punch like other animals. It launches a club like a spring-loaded hammer. The strike can reach about 80 kilometers per hour. That speed happens underwater. Water should slow everything down. Instead, the punch creates a cavitation bubble. When that bubble collapses, it adds a second shock. So prey gets hit twice. First the club, then the imploding water. Myth says the shrimp only wins through strength. The truth is timing. Its limbs lock, store energy, then release explosively, like a crossbow trigger, only alive. Its eyes are just as wild. Humans use 3 color channels. Mantis shrimp have far more receptor types. Researchers still debate exactly how they process that information, but their visual world is clearly not ours. A reef crab sees danger. The shrimp sees angles, contrast, and armor weaknesses. Then comes the hit. And on land, another animal rebuilds what should stay lost. Cut to a pink salamander with feathery gills. A leg goes missing. Weeks later, the leg returns. Not a scar, not a stump, a working leg. The axolotl is a regeneration champion. It can regrow limbs, tail tissue, skin, and parts of organs. Researchers study its heart repair closely. Its spinal cord can repair too. That alone sounds impossible. But the real trick is cleaner than simple growth. The animal does not just patch damage, it rebuilds patterns. bones return in the right order, muscles reconnect, nerves thread back into place. Most people think healing means closing wounds fast. For axolotls, smart rebuilding matters more. Cells near the injury reset into a flexible state. Then they divide and specialize again. That process is called a blastema. It is like the body reopening old construction plans. Scientists hope those clues may help human medicine someday. Not tomorrow, but the blueprint exists in nature already. And now the story lifts from bodies to sound. In an Australian forest, a bird sings a camera shutter, then a car alarm, then a chainsaw, then another bird perfectly. The lyrebird is not mocking badly, it is copying with shocking precision. Males build long display songs from borrowed noises. They imitate rival birds, local habitats, and human machines. That sounds funny at first, then it gets eerie, because the copy often keeps rhythm and texture. Researchers recorded birds reproducing mechanical sounds from vanished places. The machine disappeared. The sound remained in the bird. That makes a forest feel like an audio museum. Myth says mimicry is just party trick intelligence. The truth is survival and courtship. A complex singer can impress mates. It can also blend into a loud environment. The mouth, throat, and brain coordination must be exact. One wrong tone ruins the illusion. Yet the bird keeps the pattern. So one animal freezes, another shoots, another punches. This one archives sound itself. And next comes a bird that treats thin air like home. The bar-headed goose migrates over the Himalayas. That sentence should already sound wrong. Humans struggle there with heavy gear. This bird crosses on muscle and timing. Flights can exceed 70 meters altitude. Air up there holds much less oxygen. Cold cuts performance too. Yet the goose keeps going. Its lungs and blood are tuned for efficiency. Its hemoglobin grabs oxygen more readily than ours. Its breathing system also moves air differently from mammal lungs. Bird lungs are astonishing machines. Air flows through them more continuously. That helps during extreme flight. Researchers tracked these geese near mountain passes and high ridges. They do not always choose the very highest route. That is the smart part. They use winds and terrain carefully. Still, even reduced routes remain brutal. Imagine flapping through freezing darkness beside stone walls and jet stream air. Now remember, the bird is doing this repeatedly. No engine, no oxygen tank, no rescue team. And if that sounds like the peak, another flyer turns gravity into a weapon. A pigeon flaps, a goose climbs, then a peregrine folds its wings and drops. The sky becomes a hunting trap door. Dives can exceed 320 kilometers per hour. That is faster than many racing cars. The strange part is control. At that speed, small mistakes become disasters. But the falcon has built-in solutions. Special baffles in its nostrils help manage rushing air. Its body shape cuts drag. Its eyesight is absurdly sharp. It can track prey from far away, then correct mid-dive. Most people think top predators always win through size. The truth is design. A peregrine is not huge. It is aerodynamic. Its feet strike like closing hooks. Its descent turns height into impact. Researchers studying urban falcons found skyscrapers mimic cliff habitats well. Cities accidentally made falcon towers. Pigeons became flying targets between glass canyons. So the fastest dives now happen above traffic and rooftops. Nature did not leave the city. It adapted around it. And under dark water, another hunter attacks without touching first. An electric eel does not need teeth first. It sends a command through water. The prey twitches. Then it gives itself away. That is the part many people miss. The eel uses electricity for more than shocking. It can probe. It can map. It can force movement. High-voltage pulses trigger prey muscles remotely. The prey jerks. That tiny jerk reveals location. Then comes the stronger attack. Researchers showed eels can make hidden prey betray themselves. That is like pulling an invisible tripwire. Large eels can produce around 600 volts. Voltage is not the whole story, but that number gets attention fast. The body is packed with specialized electric cells. They work like stacked biological batteries. One cell is weak. Thousands together are not. Myth says the eel is basically a water cable. The truth is smarter. Low-voltage signals help sense surroundings. High-voltage bursts help hunt and defend. So the same animal scans and strikes with electricity. And another ocean mind does something eerier. It edits its body like moving software. An octopus approaches a crack thinner than your thumb. Its head pauses. Then its entire body pours through. Bones would stop almost everything else. The octopus has none. If its beak fits, much of the body can follow. That makes containers, pipes, reefs, and wrecks full of possibilities. But flexibility is only part of the shock. Its skin changes color fast. It also changes texture. A smooth arm can become a knobby, rock-like surface. That means camouflage is not only paint, it is shape too. Special cells handle pigments and light reflection. Muscles under the skin raise tiny bumps. Researchers watching reef octopuses recorded astonishing rapid disguise shifts. 1 second, pale sand. Next second, dark coral shadow. Its nervous system is strange as well. A large share of neurons sit in the arms, so movement and exploration are partly decentralized. That gives the animal fluid problem-solving. Most people think intelligence must look human. The truth is tentacled and distributed. A jar becomes a puzzle. A crevice becomes an escape route. And the next creature gets even smaller while surviving much worse. The tardigrade looks like a tiny walking bean. Under a microscope, it seems almost cartoonish. Then you learn what it survives. Heat can hurt it. Cold can hurt it. Radiation can hurt it too. But when conditions turn brutal, tardigrades have a backup plan. They dry down into a protected state called a ton. Their metabolism drops dramatically. Water loss becomes a defense. Without much water, damaging reactions slow way down. That matters in freezing, drought, and other extremes. Researchers revived tardigrades after long dormant periods. They are not invincible. That myth is wrong. But they are astonishingly resilient. Many are smaller than 0.5 millimeters, so one of nature's toughest animals is nearly dust-sized. Proteins inside tardigrades help protect cells during stress. Scientists are still studying how those molecules work best. That is the exciting part. The creature is real. The full toolkit is still being decoded. And the next animal proves even sound can become a weapon. On a reef, a tiny claw snaps shut. A bubble flashes. Nearby prey goes still. That is the pistol shrimp. Its claw closes so fast, water cannot move aside normally. Pressure drops. A cavitation bubble forms. Then it collapses violently. The collapse creates a loud pop and shockwave. It can stun small prey instantly. Most people think the shrimp wins with pincers. Turns out the bubble does the heavy work. The snap can reach around 210 decibels underwater. That is one reason shrimp colonies sound like crackling rain. Some submarines even notice shrimp noise. Tiny animals can dominate whole soundscapes. The shrimp itself is often only a few centimeters long, so the scale feels ridiculous. Smaller than many house keys, louder than you would expect from a hand-sized creature. Scientists filmed the flash from collapsing bubbles in lab tanks, so yes, the pop is visible for a moment. One claw, one bubble, one stunned victim. And now we reach the strangest life reset of all. Imagine an animal growing old, then turning young again, not in a story, in the ocean. The so-called immortal jellyfish does something close. When stressed or damaged, it can revert to an earlier life stage. Instead of continuing toward death normally, it can restart the cycle. It does not mean nothing can kill it. Predators can. Disease can. Accidents can. Myth says it lives forever untouched. The truth is more elegant. It can repeatedly sidestep aging under the right conditions. That reset happens through cellular reprogramming. Adult tissue transforms back toward a juvenile, colony-like stage. Then development begins again. Researchers confirmed this reverse transition in the lab decades ago. That discovery still sounds like a science fiction draft, yet it drifts in real oceans. Tiny,